Hello, everybody, and welcome to another exciting, action packed episode of Classic Arcade Repairs. Today, I just got out onto the bench. Who can guess what this is? Pretty special one today. Any guesses? You can pause it and kind of guess if you would like. Actually, it'll probably be given away by the title of the video. Anyway, this is a computer space board set. The very first commercial arcade game. Computer space. 3 boards. I do have the cage that goes along with it. And the owner of this sent along this little power supply right here, which I'm getting ready to test. I have this. It's 3 4-ohm resistors, 3 4-ohm power resistors in parallel with each other to bring it down. It's probably 1.5 ohms or something like that. It's probably around 3.5 amps of draw on a 5-volt supply. Something like that, 3 to 4 amps of draw. I could do the math and find out exactly, but that's about what it is. I'm just going to test this thing and make sure that it's at 5 volts with that draw so that this is going to be adequate. So I got that thing ready to go. We'll do that in a minute. But this board is looking really rusty and crusty. The rest of them aren't so bad. A little bit of rust and crust, but not too bad. So this one must have been on the very outside of the stack because it's got the brunt of the rust. Yeah. Anywho. Okay, yeah, first things first, I'm going to go ahead, test that power supply, make sure it's going to put an adequate 5 volts to this under load. I can't imagine this would draw any more than 3 amps, so 3.5 to 4 amps will be fine on that as a test. Yeah, so let's get to it. Computer space. Okay, so we are ready to go. We're on DC voltage. So let's go ahead and turn this thing on. And okay, it is at 4.92. I got big 25-watt power resistors here to dissipate that heat, and it's dissipating well. It's not even really, I mean, it's slightly warm. But yeah, that'll do just fine. This little guy, little 5-volt supply, pretty cool. Thing's tiny. Yeah, it's a little warm. It's warming up a little bit. All right, cool. This thing passes the test. That'll be just fine. All right, I just kind of put the first board in and poked around on this board, and I did find one absolute bad chip right here. That's a 20. And if we look at the inputs of the 20, oops, you see there's the first input. Here's the second. It's a 4-input NAND. There's the third. There's the fourth input, and the output is this. So that is definitely, that's the only chip that I've found so far on this board that is bad. Some of these I can't even, I don't know what they are, I can't read them. So there is a schematic for this that I'll have to get out and look at. But I just wanted to kind of preliminarily just kind of poke around here, look at, chips. If it like a 20, I know what a 20 is, so I'll just probe it really quick, and if it's obviously bad, mark it bad. So yeah, so there's definitely one right there. Now I could put in another board and do the same thing. That way I kind of just eliminate, obviously bad chips. So I think I'll do that with the next board. Throw it in there, do the same thing, just poke around on it. And before I get into more in-depth stuff, I might end up fixing the thing just by doing that. Who knows? We'll see. I will continue on. Okay, so I went through the schematic as good as I could, and listed all of the chips of what they are. Because you can't read the tops of most of the chips. I got it pretty well filled out. Looks like I'm missing one right there. There's a few chips that I couldn't find on the schematic that I could probably find if I went back over it again. This one's complete. And this one, I believe, is one right here that I don't have. And this one up here was one of those 93 numbers that I think it said 9324. I wasn't exactly sure though. So I'll have to investigate that a little further, I guess. But I think one of the first things I'm going to do with this board set is replace the capacitors. We're talking 50-year-old caps, so yeah, I'll go ahead and replace all of those. Man, this board has got a lot of rust and stuff on it. It's not looking healthy. But we'll take a look at this. I've got most of this mapped out. I think this is the one that I didn't. Anyway, these caps are going to have to be replaced. So I'm going to do that first thing. And a lot of these diodes are busted. And these, I believe these diodes are what create the outline of the rockets, I believe. So any of these diodes that are busted, I'm going to go ahead and replace. There's quite a few of them that are broke. So, all right. Let me take care of all of that off camera, and then I'll be back. Okay, so I went ahead and did a lot of work on this thing. I removed every one of these diodes because a quarter of them were broken and 100% of them were really brittle. So I just went ahead and removed them all, and I'm going to replace them all. I tried cleaning this up a little bit. There's still a lot of rust. I don't know. I got new caps. I recapped up here. Looks really nice. But the good news is a lot of this stuff is just common TTL. These aren't exactly common. These are 150, 74, 150. This is a 154, which is somewhat common. So if any of these don't work, and I just don't, I mean, them being rusted, I don't like that. I kind of want to just order some parts to replace this rusted out junk anyway. We'll see. I cleaned the board up. I cleaned it. It looks decent. I think the first thing I'm going to do now is re-diode all of this. I took pictures. So I'm just going to re-diode this stuff and then look at what am I going to do about this stuff, this rusted board. We'll see. First things first, let me re-diode this section. All right, and I was able to get that many done. I still have to do these. I ran out of diodes. So I will order more diodes, and while I'm at it, I'm going to order some more ICs. And I'm going to put this one on the back burner, move on to something else for now, but I will get back to this when I get some parts. So I'm going to go inside right now, and I'm going to start ordering some stuff. So, all right, very good. I will be back. We will be back to move forward with this guy. I'm very happy with this. This is nice. Nice new diodes in here. No longer are they just brittle. Break. You touch them, they break. You know, that's how those were. So I just decided to pull them all and replace them all. I like it. All right. All right. And just for fun, I used my 2 capacitor testers to check these old caps. And we had 2 of the 10 microfarad caps that were open, and the rest of them actually tested okay. They all drifted a little high in the capacitance, but they weren't bad. But yeah, 2 of them were open, so interesting. All right, so that is it for now, really. I think I'm going to, now that I do have a legend of the chips that are in the board, I'm going to do another poke around session with the analyzer and see if I can't find any more bad parts before. I just put in an order for some chips and more of the diodes, so I got that coming to finish that up. And I ordered like 6 of these 150s. I ordered a couple more 154s, the big one. And a couple of the oddball stuff that's on these boards I ordered, like a 7453. There was a handful of those on here. So I ordered some of that oddball stuff, just a few of them to have. So we'll really pick this back up when I get those orders back. But I can throw these back on and just poke around a little bit more now that I know what's what. And just kind of see if I can, you know, quickly find anything that's obviously bad. So I'm going to do that, and then we'll just be waiting for the order of parts to come in. And I ordered an awful lot of capacitors too. I had to restock my capacitors, so I got a lot of caps coming, and diodes and parts and chips and stuff like that. So, all right. We will return. Alright, so preliminarily, and remember I'd already replaced this guy, the 20. I have found what I believe to be a bad chip right here and a bad chip right here. And those are both 00s. And if we look at this one, a 00 is a not AND gate. So you need 2 high inputs to get a low input. And if we look at the first input, it's low all the time. Yeah, this one's actually okay. I was thinking about this wrong. You need two high inputs to get a low, so the output is going to be high all the time. The second input is toggling, and the output is always high. So this one is actually okay. Yeah, that one's actually okay. I was just looking at that wrong. So let's switch that over to green. Now this one down here is definitely not good. If we look at this, here's the first input. Low. And remember, you need two high inputs to get a low. So right here, right off the bat, the output should be high all the time. And here's the second input, which is also 0. So we should have high on the output. And here's the output. The output is floating. So that is a floating output. That's definitely no good. So it turned out there were two bad chips on this board, it looks like, from what I can gather so far. So I'm going to go ahead and replace that 0, 0 right there. And then I will put this board in, and we'll start poking around on this one. And I've actually done some preliminary poking around on this one, and I poked around on all of these counters. These are all 161 counters. There's 16 of them, 4x4. And they all looked to be just fine, which is nice. So we'll just go around the outside of everything else that's on here and just kind of poke around and get a look at everything. So let me go ahead, stop, replace that, and then I'll be back. Okay, well, that chip, this one here that I replaced, actually tested good. It's right here. It actually tested good on both this tester and inside on the TI-8662 tester. And I got to looking at this, and this here, this chip, on the output pin, if I pull the pin out of the circuit, it's high, right? Now bear with me 1 second. I will turn this off, and I'm gonna put that leg in circuit and turn it back on. Okay, now I have this chip back in circuit, and that output pin is floating. What I noticed is, I traced it out. It goes to this diode right here. There's a diode right there. That output pin comes to right here. Okay. And there's a low potential on this side of this diode. So what is going on is this thing is voltage dropping across this diode. So they're using that digital output in an analog circuit. It's just weird, you know. This old stuff like this does weird stuff. So that's actually how that's supposed to be. So interesting enough. Anyway, I'm going to continue on. I think everything else is, I'm just going to leave this chip in the board. And I think this, I recapped this board, put new caps in it. You can see this one here, that one, and these down on along the bottom are new caps. So this board should be good to go. So I'm going to put another board in it, put the next one in there, and kind of poke around on that one and make sure everything looks decent on that board. Okay, got the gun heating up. We have an LS86 that was clearly bad, had a floating output. And this is a 00 that technically probably isn't bad, but I did not like the way one of the output pins was behaving. it was high, which it was supposed to be high all the time, but it was going like above 5 volts high. Like it was just weird. Either that or it was at about 4.5 volts and it would shoot up to the voltage rail. I just didn't like that, how it was acting, so I'm going to replace it. This one was just clearly bad. So, all right. Yep. I'll replace those two guys. I'm going to replace the caps. And this broken capacitor, I'll replace that one. And this board will be done, I think. So, yeah. Then it'll be on to the one that I have to finish. So I'll be done with it until I get my parts and stuff. My diodes to finish that. And then we can go over that one. All right. All right. I replaced the LS86 and the 00 down here. And as expected, the 00 did test good, but I just did not like how it was jumping from up to the voltage rail. Was weird. And the 86 was absolutely no good. So, and I replaced the capacitors. Now these two right here were 250 microfarad originally, and these were 100. Well, I don't have any 100, so I put 220. 220 microfarad in all 4 spots, which will be absolutely fine. And I have to replace this guy. I forgot I pulled this out. So I'll replace the 0.1 right there, and this board will be done for now. All right, and after further review, this board is pretty much toast. It's got a ton of chips with floating outputs. Some of them look good. I think this board's going to get a complete rebuild. There's not that much on it. But it is bad news. So I'm going to go through this thing, and I'm going to remove every chip on this thing. And every chip will be socketed. It's just is what it is. You know, this board right here is just bad. So rusted, crusty, and bad. So needs to be done. Otherwise, this thing, I mean, I'm already having to replace half of the chips. So I might as well remove them all. I might as well renew this board, is what I'm getting at. Is it just needs to be done. So, all right, I'm going to get to work desoldering all of these parts. All right, well, I have a lot cleared out here. Never mind the air compressor in the background. But yeah, I cleared off this whole front row here, and then all of the red dot chips. I left the green dotted ones in for now because this is an awful lot to do. So I'll be breaking my new diodes already. Yeah, so we're going to socket all of this, and I cleaned it up. Hence the air compressor running. But we're going to put sockets in here. I had to desolder both sides of this board. This solder was so old and crusty, I had to desolder the top side and then turn it over. I had to pick all of the pins out. I had to cut the chips off, pick out the pins, desolder the front side, and then desolder the back side. There was so much crusty solder on each of these that I had to do both sides. But it came good and clean though, so yeah. Yeah, they're all good and clean. So we'll go ahead and socket this. And yeah, go ahead and repopulate with sockets. So I guess I'll go ahead and do that now. Okay, so now we're getting somewhere. We are repopulated with our sockets. It's beautiful. These old boards are easy to work on. They're very easy to desolder and stuff like that. Well, they're easy to make look good. Let's put it that way. They're easy to not tear up. Alright, so we've got some crusty chips remaining, but they tested good. So these ones I don't know about yet. I did not probe those guys, and hopefully they're good. That's all I can say is hopefully they work. But we'll see. I'm going to go ahead and repopulate this board with chips. I have everything I need for this board, so I'll go ahead and populate this thing up, and we'll take a look at it. All right, I got that board populated and put back in. I readjusted the voltage. I actually had to crank it down a little bit because those bad chips were really causing it to, it was causing more draw. So I readjusted this. It's at about 4.9 volts. And all of these chips, the signals look fantastic. This is outputs on the 86s. And now we've got just great looking signals everywhere on this board. And these muxes were absolutely dead before. Now they just look beautiful. Yeah. The 0 zeros. 2 1s to get a 0. I don't see anything floating anymore. That'll be high all the time, yeah. So oop, that's floating. Yeah, that's a floating output right there. This is a 151, and that is pin 6 is the output. So yeah, well, that one's no good. See, we've replaced and made a bunch of chips good, and now I'm finding more stuff that's actually bad because it's actually getting signals to it now. But yeah, so that 151 has to be replaced. And yeah, this is awesome. I'm going to go ahead, continue to poke around a little bit, find some more stuff that's, if there's anything else looking suspect, that's definitely bad. And that guy interfaces, I believe, this is the saucer, I think. This puts the saucer together, maybe. These diodes right here, these four, they form the rocket in different stages of spinning, I believe. Different way it looks. And this is the saucer, so this is the output to that. So yeah, I don't know. We'll see. I'm gonna continue probing around. I know that guy's got to be replaced, so continue looking around. But yeah, this is nice now. Everything's looking great. Alright, yeah, right off the bat, this is a 154. And the way this works, it's basically a 16-bit decoder. It's a 4 input 16 output decoder, and it's got two enables right here, and they're both low all the time, so this thing is always enabled. And we have inputs here. These are the 4 input bits from least to most significant, these 4 bits. And if we look at these, this is the first one, this is the next one, this is the next one, and the last one, most significant. So we have good bits going into this thing, and it's always enabled. And the 0 output is right here on pin 1, and you can see the 0 output is floating. This guy's no good. So far the 151 and the 154 are both bad. And that's, you know, that was probably floating the whole time. I just never probed this. But so far these two have to be replaced. Yeah, so, and these guys right here are probably functionally similar to this. I don't know for sure. I'll look it up in the big TTL book. The 150s. Yeah, these, they form a matrix. Like this enables the cathodes or anodes of these, and these put a logic low signal on either the cathode or the anode, whichever one. They form a matrix that turns on these diodes, basically, which will project onto the screen what the rocket looks like. That's how that works. And this one obviously does not work at all. So this has to be replaced. Okay, so I looked in the big data book, and these guys right here are nothing like this. This is a 4-line to 16-line decoder. These are 16-bit to 1 selector. So this selects from one of 16 bits and outputs on one line. Pin 10 is the output. And if we just look at pin 10, actually, here's 9 is the enable. This is 9. And it's enabled low. So it is low. Low. They're all low. So they're all enabled. And here's the output on 10. And you can see this looks like it has a good output, which is good. This one also, the next one, is looking like a good output. The next one, once again, looks like a decent output. It looks like a digital signal anyway. Now this one, pin 10, this one's dead. This one has no output. Yeah. And these are the input. These are the select lines. Right here, and then these 3 guys. Yeah, 1, 2, 3. So this thing should have a signal similar to this, but it has this. So this one's no good. That's a dead signal. So I'm going to say these 3 chips are no good. These 3 are potentially good because they have digital looking signals on them. So we have 3 good, 3 bad. So these 3 are going to have to be replaced. And I don't have any 150s. I did order some, so hopefully the source that I ordered them from is not out of them. We'll see. But this one's definitely no good. You'll never get the rocket to look like this with this thing not working. So, yeah. Boy, this board was bad. But yeah, so All right, I'm gonna go ahead. These three guys, I'll put red dots on these guys. These ones definitely have to be replaced. I'm gonna look at the rest of these chips just to double check that they do look good now. Maybe they have signals they didn't have on them before, so I can double check now. So I'm gonna do that. Okay, I have replaced the 154, 151. I have a socket for the 150. I don't have those, but I have the socket for it. And if we probe that same pin number 1, remember, was floating. Now we have our good signals. That's the 0 bit. 1, 2, 3, and so forth and so on. And then this guy, remember, pin 6 was floating. The outputs on this are 5 and 6, I believe. You have 5 and then 6 is the inverted. So yeah. So now we got good signals there. So I just wait for this and my diodes. I got this chip coming and I got diodes coming to finish this board. And this thing, hopefully, this should be good to go completely. We'll see. I kind of am at a standstill now, though. I can't really do anything else until I get my order of parts. But boy, we did a lot. We got a lot done on this. This thing was terrible. Floating signals everywhere. But yeah, so all right. All right, I'll see you back once I get my parts.